Number 7. This question is from work, power, and energy. A car of mass 1200 kg is traveling along a straight horizontal road. Mass of the car is 1200 kg traveling along a straight horizontal road. The power of the car engine is constant and is equal to 16 kilowatt. Power is given in kilowatt, but we will convert it into watt multiplying by 1000. There is a constant resistance to the motion of magnitude 500 Newton. The resistive force is 500 Newton. Part A of this question is find the acceleration of the car at the instant when its speed is 20 meters per second. This can be the diagram for this, a simple diagram. Horizontal road, and this is the car. This is a car moving on this side. Opposing force, force of friction, resistive force, a force of friction. F is equal to 500 Newton. This is given. Now, what will be the driving force on the car? Now we have given the power of the car's engine 16 kilowatt, converting it into watt for standard unit 16,000 watt. This is power. Resistive force is 500 Newton and V is 20 meters per second. This is data for this question. Now first we will use Newton's second law of motion. What will be the driving force? We know that this is formula for power. P is equal to F into V. But we need force. Force from here we make the force F subject P over V. Now we have value of P is 16,000 and V is 20. So we get 16,000 over 20 to find driving force. So driving force will be P over V. Now a net force will be driving force P over V minus force of friction, that is 500 Newton. P over V, this is driving force moving on this side. Car is moving on this side, but opposing force is 500 Newton. So net force will be P over V minus small f. Small f shows the force of friction or resistive force is equal to ma. This is Newton's second law. Putting the value of F, V, and P and mass, we get the acceleration. P is 16,000, V is 20, minus force of friction is 500. Mass is given, that is mass of the car is 1200. So mass is 1200 kg. 1200 A. From here we can find the value of A. So simplifying left hand side, we get 300, right side 1200 A. From here, A will be equal to 300 over 1200. We get A is equal to 0.25 meter per second square. This is the answer, or this is the acceleration of the car. Part B of this question is assuming that the power and the resistance forces remain unchanged, find the steady speed at which the car can travel. Now for steady speed, acceleration will be 0. For steady speed, shows that acceleration is 0. Again, we are using Newton's second law of motion. Net force will be P over V. This is the driving force minus force of friction is equal to ma. Since acceleration is 0, so right side will be 0. Putting the values, we have to find a speed. We have to find the speed of the car, that is steady speed 16,000 over V minus 500 is equal to 0. 16,000 over V is equal to 500. From here, uh, V is equal to 16,000 divided by 500. We get finally steady speed will be 32 meters per second. This is the answer, 32 meters per second. Now next part C of this question is the car comes to the bottom of the straight hill of length 316 meters, inclined at an angle to the horizontal of sine inverse 1 over 60. This is the value of theta. Theta is sine inverse 1 over 60. Inclined plane making an angle sine inverse 1 over 60 to the horizontal. The power remains constant at 16 kilowatt. 16 kilowatt means in this part uh, power is constant and 16,000 watt, but the magnitude of the resistance force is no longer constant and changes such that the work done against the resistance force in ascending the hill is 128,400 joule. This is the the work against friction is given, that is 128,400 joule. The time taken to ascend the hill is 15 seconds. This is the value of t. Now, given that the car is traveling at speed 20 meter per second at the bottom of the hill, find the speed at the top of the hill. So first we make the diagram. This is horizontal road first. The last part, the car was traveling on a horizontal road. Now the car is moving on an inclined plane. This is inclined plane. And this angle is given that is uh, theta is equal to sine inverse 1 over 60. It is given in the question. Inclined plane is making an angle. Sine inverse 1 over sine inverse 1 over 60 is actually the value of theta. So this is theta. From here we can find the value of sine theta, that will be equal to 1 over 60. Now we will use here data is given that power is 16 kilowatt. We convert it into watt, 16,000 watt. This is the power of the car's engine. Now work against the friction is also given. During the motion of the car along the inclined plane, the work against the friction is given. We are representing this work against friction as, we will use short form work against friction. We are denoting WF small. This means that work against friction, this is given 128,400 joule. Now, speed at the bottom, this is the bottom of the inclined plane, and this is the top. Speeds at the bottom is given, that is 20. Let this point is A. Suppose this point is A point at the bottom, and this point, let this point is B. And this distance along the plane is given. The distance AB is given, that is 316 meters. This is 316 meters. Now at point A, speed is given, that is 20 meter per second. At point A, the speed of the car is 20 meter per second. At point B, we have to find the speed of the car. Now, since we are given the time 15 seconds to reach from the bottom to top, and distance is also given. Now we have to find the driving force along the plane. So we know that in this part, we know that power is equal to rate of doing work. W over time is power. So from here, this W shows the work done by the driving force. So we can find the work done by driving force will be P into T. This is the work done by the driving force. So work done by driving force, we are representing it by WD. Work done by driving force, WF, work against friction. Work done by driving force by using uh, this formula P into T. P is 16,000 and T is given, that is uh, 15 second. 15 second. T is given 15 second. Now P into T will be the driving force. So driving force will be 16,000 into time, that is 15. We get this 24,000,000. This is work done again by driving force. Now we will use here work energy relation. Work energy relation, that is, or we can say work energy method. Work energy, what is work energy method? We will use these two works and energies here. Work energy relation. This is very important formula. Work done by driving force will be equal to work against friction plus change in mechanical energy. This delta shows change. But mechanical energy, sum of potential energy and kinetic energy is mechanical energy. So first we find mechanical energy at point A and B. This is first we have the value of WD and WF putting here. After that, we will find the change in mechanical energy and putting the values in the formula. We get uh, the P. So work done by driving forces given we have found 24,000,000. Work against friction is given 128,128,400. And what is change in mechanical energy? Final mechanical energy minus initial mechanical energy. We will subtract, we get change in mechanical energy. So first we have to find the mechanical energy at this point A and mechanical energy at point B. Mechanical energy actually the sum of potential energy and kinetic energy. So let this is equation 1 for reference. Now first we will find mechanical energy at A. Mechanical energy at A point. At A, this is point A. Here mechanical energy, because this point A is on the horizontal road, so no height, so mechanical potential energy will be zero. But because the speed, car has speed at this point 20, so kinetic energy will be here. So mechanical energy will be at A will be mgh plus 1 over 2 mv square. Since the height is 0, so mechanical potential energy is equal to 0, and kinetic energy 1 over 2 m is 1200, v square, v at A is 20. So simplifying, we get 20, 24 00 and 00. This is mechanical energy at A. In the same way, we will find the mechanical energy at point B. This point is B. To find the potential energy at B, we need this height. How we will find this height? Let this height is h. Easily we can use ratio to find h. Perpendicular this distance A, B, and this point A, B. Let this is C. A, B, C is a right angle triangle. We can use a ratio sin theta perpendicular over hypotenuse. The side is given 316. So we can find a h. So h will be, we can find h by using This ratio h over 316 perpendicular over hypotenuse is equal to sine theta. Now we have the value of sine theta. It is given 1 over 60. So putting the value of sine theta, h over 316 is equal to 1 over 60 from here. Height will be 5.267 meter. This height we have found to find the potential energy at point B. So now we will find mm, uh, mechanical energy at point B, sum of potential energy and kinetic energy, mgh plus 1 over 2 mv square. mgh we have m, g and h. Putting here the values 1200 m, g is 10, height just we have found, that is 5.267, 5.267 plus 1 over 2 m is 1200, and v square we have to find v at b. V we have to find at point B. So now simplifying it, mechanical energy at B, simplifying these terms, we get it 63204 plus 600 V square. Now from equation number 1, now in this equation 1 we write here change in mechanical energy. Change means final mechanical energy minus initial mechanical energy. Final mechanical energy is this, and initial mechanical energy is this. So from equation number 1, uh, from equation 1, 240000 is equal to 128400 plus change in mechanical energy. Final mechanical energy is 63204 plus 600 V square minus initial mechanical energy is 240000. Now simplifying it, we get 240000 is on the right side. Simplifying these terms, on the right side we get 600 V square minus 48396. From here, after calculation, we get the value of V. Finally, we get value of V from this equation. V will be 21.9 meter per second. This is the answer, 21.9 meter per second speed at point B.